Math 7-6, lesson 78, just like our last lesson, lesson 77, we're going to rely on some information in the book to help us sort out what John wants us to know. This time what we're doing is we're classifying. That sounds like there aren't a lot of numbers involved. Quadrilaterals. If you're in the mood for an art project, then you're in luck, because that's what we're doing. All right, I'm going to show you the book so that I don't have to copy all this and use a bunch of time. Okay, if you can see, and I'm on page 377, so if you want to pause me and go get your book and open to 377, it will help you in the long run. I'll wait while you go get it. Okay, you're back. So we're going through these shapes here, and the main thing that we're talking about is parallel sides. That's what we're going to be paying a lot of attention to. But these are quadrilaterals. Lateral means side, and so they're four-sided shapes, right? And they're all polygons. They're blah, 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 all those rules. Okay, the first one is called a trapezium. What? And the weird thing about these is that they're random. No sides are parallel, okay? That one looks like an iceberg to me, but it could just be me. The next one is called a trapezoid, which is weird because there's a muscle named trapezoid, I'm pretty sure. But anyway, they have one pair of parallel sides. Notice that the top and the bottom are parallel, but the two sides are wonky-ish. So that's one pair of parallel sides. All the rest of these have at least two pairs of, they'll have two pairs of parallel sides, all of them. One pair, no pairs parallel, one pair parallel, two pairs parallel, all the way down. The broadest category is called a parallelogram, and that is any shape where one set of sides is parallel and the other set of sides is parallel. A parallelogram is the broadest category. These three are all kinds of parallelograms, so we're getting more specific here. What's special about a rhombus is it still has the squishy sides, but they're all the same length, okay? A parallelogram with right angles is called a rectangle. Oh, we're starting to feel familiar, right? So if you square up the sides and make it perfect, that is a rectangle, and if you square up the sides and make them perfect corners and have them all the same length, that's a square, okay? About that. Okay, page 377. Now, all we're going to do in this, let me just write that down. Page 377 is the table. And I'm going to make a few notes that the trapezium had no parallels. Trapezoid had one pair of parallel sides, and then the parallelogram with the subsets of the rhombus, the rectangle, and the square. Oh, I forgot the S. Okay, these are all subsets of that. All of these of sides, okay? So that helps you focus on what John's going to be interested in. He gives us one example to solve, and it is a statement that we're supposed to decide is true or false. And I'm just going to put the book back so I don't have to write it all out. Ready? He says, is the following statement true or false? All parallelograms are rectangles. So let's look at my list right here, because I knew what he was going to be asking and I prepared for this. He says all parallelograms are rectangles. Well, a rectangle parallelogram, but there are two other kinds, right? So that all the opposite, though. You could say that all rectangles are parallelograms. But the way he wrote it in example 78.1 is big fat false. Okay, so that's what you're doing in the practice as well. Some parallelograms are trapezoids. Every square is a rhombus. Every rhombus is a square. Some rectangles are squares. This is somewhat confusing and picky. I'm going to show you the answer to the last one. A square is considered a rectangle with equal sides. So it would be true that some rectangles are squares. That would be true because a square is a kind of rectangle, but of course there are other rectangles too that don't have even sides. So this is super picky. I will be honest with you, this is not really important to me because we're not going to build a lot on this, and you'll get more used to these concepts as we work with them more. So if you find this practice scenario to be super frustrating, do not let your math volcano erupt. Promise me this is not worth getting upset about. So frustrated, reach out to me, have your mom text me and say that you're annoyed. But don't let this blow your silly kind of, but it's just not that important. So don't waste your emotional strength freaking out over it. Do you hear me, Joel? Don't freak out over this. All right? Okay, that's it for lesson 78, you guys. I will see you in lesson 79.